Now we want to be able to calculate the ripple voltage. Okay, ripple effect is this effect where you see increase down, decrease down. It looks like a ripple. So this is we call it the ripple voltage. The capacitor reaches its peak value when the input signal is at its peak. Okay, as the input decreases, the diode become reverse bias. Right, we already explained just now, right, the discharging of the resistor. So now we want to be able to calculate the output voltage. So just now we looked at how the shape looks like. Now we want to calculate. So the output voltage V out equals to Vm times exponential minus t prime over tau. Okay, I hope you can see this in the video clearly. So t prime is the current time. The t prime here is any time that you wanted to measure the output voltage. Tau here is the time constant. Tau is the time constant of the circuit, and the time constant is actually RC, the value of the resistor times the value of the capacitor. So if you know Vm and you know the time that you want, you'll be able to calculate the output voltage. Now if you look at the circuit here, there are two main things that you should concentrate. If I zoom in, you have the Vm and the Vl. So Vm is the maximum here, and Vl is the lowest of the output voltage. Okay, so Vm is already there. Vm is the same as the input Vm. However, we want to be able to calculate Vl. Vl is the equation is given here. Vl equals to minus Vm times exponential minus t capital T prime over RC. So capital T prime is this here, where it's from the time it's charged to discharge. The total time during T prime is the total time during discharging of the capacitor. Okay, so if you know the total time is discharging, then you will know the VL, the lowest voltage for the output. Okay, now what is this? Okay, so our aim is to calculate the ripple voltage. The ripple voltage here, VR, is the difference between the maximum. So you have like this, right? The difference of the maximum to the lowest VL. So VR is Vm minus VL. So this is the equation here, and you know what's Vm and VL from the previous slide. Just put the values in, then you get the ripple voltage equals to Vm times 1 minus exponential minus t prime over RC. Okay, very nice. We can if let's say we don't know the value of t prime and we want to make estimation, so below here is the estimation is method to calculate VR. So if you assume, so in order to get this, we need to assume a few things. We want to simplify to get VR. You can use this equation. This equation here can be used if you know t prime, capital T prime. But if you don't know, maybe you need to use this equation below. Here, this equation here. So this equation, you can get this by doing some derivation. First, assuming that the delta t is less than the delta t prime whenever the charging time here when the diode is on, it's always a lot less than the discharging time t prime. Therefore, for a full wave rectifier, the minimum voltage can be calculated by considering. Then you can estimate that the discharging time equals to t over 2 because the charging is too small, equals to 1 over 2f, right? And also, if we assume that the times constant RC is much greater than the period, okay, the total period of your input, expanding the exponential part and neglecting the higher order terms, it means that you do some mathematics towards it. You do here, and then what you will see that this e minus 1 over 2 f tau equals to 1 minus 1 over 2 frc. Okay, so this is can be done mathematically. VR then becomes Vm over 2 frc, or 1 over 2 fc. So this is the ripple voltage for a full wave rectifier. Okay, so the one here is for half wave rectifier circuit. So basically maybe it's easier just to memorize these two equations. So for full wave, the ripple voltage is just Vm over 2 frc. For half rectifier, VR equals to Vm over frc. Okay, right, now so let's do like a simple example over here. A rectifier circuit is given this as the input voltage with the frequency of 50, has a load resistance of 1 kilo ohm and a filter capacitor circuit of that. Calculate the ripple voltage of the circuit. It doesn't say whether this circuit is a full wave or half wave rectifier. So let's if it's a full wave, what is let's see here, let's assume it's a half wave. Okay, if in the exam they don't tell you whether it's a full wave or half rectifier, you can ask. Okay, if it's not stated, then you can just assume like me. I assume it's a half wave rectifier, so I know that VR equals to Vm over frc equals to Vm is the maximum of the input. So the maximum of the input is here, 24. So will be 24 volt divided by F, 50, the frequency 50 hertz, times R. R is 1 kilo ohm, 10 power of 3, and then C is the 10 microfarad, 10 to the power minus 6 farad. So if you do the maths correctly, hopefully you will get 48 volt. So that's how you do it. If it's because this question doesn't give the T prime, so you use this approximation for the ripple voltage. Okay, I hope you understand. If you have any questions, you may contact me to ask. Thank you.